Deep within these vast mountains of discarded technology lies a hidden treasure far more concentrated than what we find in the deepest natural mines of the earth. Every year, millions of tons of e-waste are discarded, yet few realize that these broken devices hold the keys to a sustainable and very wealthy future ahead. Look closely at these microscopic connectors. They are plated with pure gold to ensure perfect conductivity, waiting for the right process to release them from silicon. In every ton of high-grade electronic waste, there is potentially 100 times more gold than in a ton of raw gold ore pulled from the ground. This is the start of a transformation where experts identify the most valuable components to begin a complex journey from trash back into a precious royal metal. Every discarded smartphone and laptop carries a small piece of history and value, often forgotten in drawers, but now destined for a remarkable chemical rebirth today. The message is clear for the modern world. Gold is hidden everywhere in our digital lives, if only we have the vision to see and reclaim it. As the day begins at this specialized facility, the mission is simple: to harvest the urban mine and reduce the environmental impact of traditional gold mining. The first step is delicate manual disassembly, where skilled hands carefully open the shells of technology to access the rich internal components hidden deep inside. Speed and precision are essential here, as different materials must be separated at the source to prevent contamination and ensure the highest possible recovery rates. Safety comes first when dealing with batteries and capacitors. Each part is categorized meticulously to ensure that no hazardous materials interfere with the gold extraction. Classification is the secret key to profitability, as central processing units contain the highest concentration of gold, followed closely by memory modules and connector pins. A single bin of these sorted processors can hold several ounces of pure gold, making this one of the most valuable collections of material in the world. These memory modules are rich in precious metals, not just gold, but also silver and palladium, all which will be recovered through the upcoming refining steps. Every color and design of a circuit board indicates a different manufacturing era and a different yield of precious metals for the refinery to process carefully. By removing parts that do not contain precious metals, the facility reduces the volume of material that needs to undergo expensive chemical and thermal treatments later. This mechanical reduction prepares the boards for the heavy machinery, ensuring that every tiny trace of metal is exposed and ready for the next extraction phase. Every detail matters, and no scrap is too small. These connectors are often the purest source of gold plating in the entire computer architecture of today. This organized chaos is the foundation of the circular economy, turning the world's growing e-waste problem into a sustainable source of high-purity, precious industrial metals. The journey continues as the sorted materials move toward the heavy machinery, where physical force will break them down into even smaller, more manageable particles. The sound of grinding steel is the heartbeat of this stage, as powerful motors drive teeth that can shred through the toughest fiberglass and metal alloys. In a matter of seconds, what was once a complex piece of engineering is reduced to a pile of multicolored confetti, ready for the separation process. This granular mixture is the raw feed for our separators. It contains a complex blend of plastics, base metals, and the highly sought-after precious metal traces. Powerful magnets work tirelessly to remove ferrous metals like iron and steel, which are recycled separately and would otherwise interfere with the delicate gold chemistry. This magnetic extraction is highly efficient, cleaning the mixture and increasing the concentration of gold and copper in the remaining material for the next stage. Air density separators pull away the lighter plastics and dust, leaving behind the heavier metallic components that sink to the bottom of the sorting machinery. To maximize surface area for the chemical reaction, the material must be ground even finer, becoming a powder that holds the secrets of its former life. Using the simple physics of weight and vibration, the heaviest particles, which are the metals, gather together while the lighter materials are washed away effortlessly. What we have now is a rich concentrate, a blend of copper, silver, and gold that is ready to face the power of modern chemical science. Though it looks like simple dust, This powder is worth a fortune, representing thousands of hours of technological manufacturing condensed into a single heavy handful. The industrial scale of this mechanical separation ensures that even the smallest traces of precious metals are not lost to the environment during the process. Accurate measurements allow the refinery to predict the final yield, ensuring that every milligram of gold is accounted for before it enters the laboratory for refining. We now enter the realm of hydrometallurgy, where the solid metal will be transformed into a liquid state through the power of highly controlled chemical reactions. This is aqua regia, also known as royal water, one of the few substances on Earth capable of dissolving the most noble of all metals, gold. As the powder meets the acid, a violent transformation begins, breaking the atomic bonds of the gold and pulling it into a liquid solution for recovery. The characteristic orange gases are a sign that the acids are working, stripping away the copper and silver first before attacking the resistant gold particles. Heat is often applied to speed up the process, ensuring that every microscopic flake of gold is fully dissolved into the dark, churning chemical bath. The emerald color indicates a high concentration of dissolved copper and other metals, with the gold hidden invisibly within the complex chemical structure of the fluid. Constant agitation is required to ensure a uniform reaction, allowing the acids to reach every part of the metallic concentrate throughout the entire dissolution period. Filtration removes the useless fiberglass and plastic residues, leaving behind a pure, metal-rich liquid that holds the promise of the 24-karat gold we seek to recover. This amber liquid is known as pregnant solution. It is saturated with gold ions, ready for the final chemical trick that will bring the metal back. By adding a specific reducing agent, we can trigger a selective reaction that only affects the gold, forcing it to drop out of the liquid state. Watch as the magic of chemistry happens. The gold ions begin to cluster together, forming tiny, solid particles that cloud the once clear liquid in the beaker. This heavy brown mud is actually pure gold in powder form, settling quietly at the bottom as it separates from the unwanted copper and acid solution. The remaining liquid, now stripped of its gold, is sent for further treatment to recover silver and copper, ensuring that nothing of value is ever wasted. Multiple wash cycles with pure water and ammonia are used to ensure the gold powder is free from any chemical impurities that could affect its final quality. Once dry, this unassuming brown powder will be ready for the most dramatic stage of the process, the transition through fire into a solid golden bar. We now enter the pyrometallurgy stage, where the raw gold powder will be subjected to temperatures exceeding 1,000 degrees Celsius to reach its final form. The graphite crucible is designed to withstand the extreme thermal shock, acting as the perfect vessel for the birth of a brand new 24-karat gold bar. Borax acts as a cleaning agent, drawing out any remaining trace impurities and creating a protective layer of glass over the surface of the molten metal. The intense heat of the torch combines with the furnace to quickly bring the gold to its melting point, a critical moment in the refining process. You can feel the power of the heat radiating through the screen as the metal inside begins to glow with a fierce and beautiful internal light. The transition is complete. The dull brown powder has vanished, replaced by a swirling pool of liquid sun that flows with the grace of pure water. By stirring the melt, the refiner ensures that the gold is perfectly homogeneous and that every last bit of impurity has been moved to the surface. At this temperature, the gold is over 99% pure, having been stripped of its past life as a circuit board through acid and intense flame. Fire is the ultimate purifier, destroying any organic traces and leaving behind only the heavy, noble atoms of the gold that survived the electronic age. The mold must be perfectly prepared, oiled and heated to ensure the gold flows smoothly and solidifies without any surface defects or internal air pockets. This is the moment of truth. The liquid gold is poured in a single, steady motion, filling the mold with the wealth recovered from the trash. The brightness of the fresh pour is blinding, a testament to the purity achieved through the rigorous chemical and thermal steps of the modern refinery. As the temperature drops, the gold regains its solid structure, capturing the light in a way that only this specific element can truly achieve on Earth. The sudden quench in water cleans away the borax glass and rapidly cools the metal, finalizing the transformation from liquid fire into a solid treasure. Emerging from the water, the bar is now a solid reality, a physical manifestation of the value that was once hidden inside a pile of broken electronics. Every bar recovered is a victory for the environment, representing gold that didn't have to be mined using destructive traditional methods in fragile ecosystems. The cleaning process removes the final residues of the smelting flux, preparing the metal for the final polishing that will bring out its legendary shine. Now, the true beauty of the 24-karat gold is revealed, a mirror-like finish that reflects the sophisticated technology of the lab that created it today. This is the gold of kings, recovered from the waste of the masses. It is indistinguishable from gold that has been in circulation for centuries. Science provides the final word on quality as X-ray fluorescence technology probes the atomic structure of the bar to verify its exact precious metal content. The result is perfection. 4 nines fine gold, the highest standard in the industry, proving that recycling is just as effective as traditional mining for purity. The final touch is the mark of the refinery, a permanent stamp that guarantees the weight and purity for the global bullion and jewelry markets. With a definitive click, the bar is certified. It is now a liquid asset that can be traded anywhere in the world as a store of value. These bars are the end of the journey, ready to be turned back into new electronics, jewelry, or stored as wealth for future generations to come. From the palm of your hand to the vaults of a bank, the life cycle of gold is a testament to the power of human ingenuity. By choosing to recycle our e-waste, we protect these natural spaces, reducing the need for invasive mining and preserving the beauty of our planet for everyone. Tasting is not just about extracting resources. It is about protecting our future by ensuring that no material is ever truly lost to the landfill. Do not throw away your old devices. Let them be reborn. Recycle for a cleaner, wealthier, and more sustainable world for all of us tomorrow.